Okay, so here I am, we're recording now, and we're going to share the screen. Ta-da, there it is. I'm reading. That's what I do. Okay. So what we're going to talk about today, we'll get into the topic of inheritance and polymorphism. And there's a few subtopics we'll build into. For example, we'll talk about visibility modifiers, which we've seen, right? So all of your public, private, protected we've seen in a few inherited methods for graphics, for example, and then the default. So we'll talk about those, and what else? We'll get into a few little things on the side. We'll get formally introduced to abstract classes, which again, we've already seen before, right? So the interface classes are abstract. We don't create instances of, say, action listener, but the methods are all there for us to borrow. But the big thing we're going to do is talk about inheritance and membership between classes. So things like all cars are vehicles, that sort of thing. Okay. So this is a quick little look into what we're doing today, and what I'm going to cover now is this idea of inheritance and membership between classes. So there we go. Okay, so imagine this big box here is a pool of memory, right? So memory for Java program. Whatever we're doing, we have some memory in it. Now, if we create, say, a string object, well, a string isn't a good example. Let's suppose we're tracking data like an employee object, okay? So suppose we have an employee object, and employee, like all classes, is a subclass of object, okay? So thus we know all employee objects are also, in a sense, objects, okay? So that's our starting point. Now, when I save this employee, I store it in memory somewhere. I'm going to call it E. Okay, well, let's call it EMP. This is an employee. Wherever it's stored in memory, it is fundamentally stored as an employee object. So there's going to be some identifier in here in the wrapper that says basically employee subclass of object. Okay, and then if necessary, you can look around and see what intermediate classes, if any, there are. But we know this thing that's stored in memory, it is an employee, and somewhere in memory it's noted that employee is a subclass of object, so Java understands that as well. Okay, so that means I have two ways that I can reference this object stored in memory, this employee. Number one is the ordinary way that we would expect, employee EMP, right, which very clearly points to this thing stored in memory. That's great, we understand that. But the other thing I can do is I can reference it as an object, which again is going to point to the same thing. So I could call it object. I could call it object OBJ, for example. And I could still have it reference this thing in memory. Why can I do this? This is okay because all employees are objects. So I know that anything an object can do, an employee can also do. Okay, so I don't have to worry that, for example, if I try to access some of its data, that data won't be there. Or if I try to access one of its methods, that method won't be in there, okay? In general, right, under normal operating conditions, yes, an employee is going to be a specialized type of object, which means employee will have some stuff that object doesn't, but it'll still have everything that object does. Does that make sense? Questions? Now we can do this in Eclipse, for example. I'll fire that up. But the key thing to note at this point, this EMP is an employee type reference. We'll get rid of that in a second here. When I use the reference EMP, I can access any of the employee data or methods. Okay, anything that's defined in the employee class, I can use. Defined in class employee. However, for an object reference, OBJ is an object type reference. So when I use the reference OBJ, I can only access the data and methods present in the object class definition. Okay? Does this make sense? I mean, this is just how Java is, right? So I guess make sense or not, this is just how Java works. So there's not really arguing against it. There is only maybe grudging acceptance. Okay? Java doesn't really care how you feel about this. This is the way Java is. Okay. Questions on this? Is any aspect of this not clear to anyone? It is normal to find this weird and disturbing. It violates everything we've learned about Java so far, except for the part that we covered this a little bit last week. Okay, you would think this employee is an employee object, and it is. It's stored as an employee in memory, but when I reference it through the object reference, that acts as a filter that I can only follow up with object type things after it. Nothing? This all makes loads and loads of sense? I'm such a great instructor. Remember that when you write the course reviews in December. Or, yeah, anyway. Okay, so we're gonna go on then. I'm gonna go into Eclipse here, and we're gonna do a little bit of this. So I'm going to make a class, and I will call this class, let's call it student. Hey, you know what, I'll call it employee. I haven't done anything with employee yet. Okay, so this is employees. They're already an employee in my, shit, it's already defined. All right, well, I'm going to call it worker then. You can be worker, and I'm going to destroy this file. Bastard. All right, you're gone. Okay, we're gonna make a file called worker. There we go. Now worker, of course, extends object, even though I don't say it does, but I'll actually just make it explicit there. Okay, so there we go, worker extends object. We already have an object class already defined in Java. It exists. But what can I do here? Well, I can give it a main method and start some stuff. So let's give worker an ID number and a string for job. Okay, so string job and int, we'll make it a long ID. Okay, and then a constructor method, worker, if we give it a string job and long ID, then we can implant those in its data. So job equals job. Okay. Instructor to assign parameters to the data fields. Okay. Now, next thing we're going to do the main method here. So public static void main string array args. We can call it whatever we want, but args for arguments, that's what the default is. Anyway, so here on our main method, I'm going to do a couple things. First, I'm going to create a worker object. So first, create a worker object, capital W. Then reference it in different ways. Okay, so worker W1, new worker, and we'll give it a string, I don't know, instructor, and an ID 2. Okay, so there we have that. And then we're going to reference it in different ways. So one thing I can do is I can print out the data. So I can do system.outline out.println w1.job, and on a new line, okay, so I can do that, and that makes sense, I hope. I'm just printing out the job and ID of that person, but I can also reference it through an object. Why reference is so hard for me to type today. I can have object OB01, I guess, equals W1. And weirdly, I can do this, again, because all workers are objects, right? But the object class does not actually store any data. It just has a few methods. So if I try to print those, I can't. Can't print through object reference. Can't print the data through the object reference because it's inaccessible. Okay, so I can't do, for example, system.out.println one dot whatever. You can see here in the help, these are the things I have. If I try to print this same stuff out, right, it lacks these things. It does not have them. I do not get to use them. I'm going to have to cover that up. So it says here, you know, job cannot be resolved or is not a field. And if I cleared that, right, I have a thing here, ID cannot be resolved or is not a field. So there we got both of those. So I'm going to comment that out. But we understand that this is wrong. But of course, I can run the program. I can print out the stuff. Ta-da, instructor 2, whatever. Okay. Questions about this? So the point is, number one, the reference you use does not have to be the same type as the reference as what the object actually is. It can be a superclass reference. That does not create any problems in Java. Because why? Because in this case, for example, all workers are objects, or all members of a subclass are also, in a sense, members of the superclass. Okay, how's everybody doing? Does that make sense? Any questions at all? How's everybody doing? I would expect the chat to be doing something by now, but it's not. We're all good? All right. Well, moving on then. Okay, so that's the big thing. Now, where this becomes useful, I guess I'll add that. One very important usage of this characteristic of Java is that you can make arrays of a superclass type that can store objects of any subclasses of that type. Okay, this is great. Might not immediately seem how great this is. This is great because you can write your code with one type of array, and even though you go on in the future and create many, many different subclasses to go with that, you don't have to store them all in separate subclasses. You can still keep it all in the one base array. This is a wonderful, wonderful thing for code maintenance. Excuse me. Okay, so let's go through. Let's start doing some lecturing. Again, this is these are old slides, but this topic in Java hasn't changed much or at all, and so they're still viable. All right, so inheritance and polymorphism. What can you do? Well, number one, write programs that are easily extensible and modifiable by applying polymorphism in program design. Basically, that kind of stuff I talked about just a minute ago, building big arrays of a superclass type that can contain objects of not only that type, but also the subclasses. Define reusable classes based on inheritance and abstract classes and abstract methods. Yeah, we'll talk about those. Differentiate between abstract classes and Java interfaces and all that. We'll talk about those. Define methods. We'll introduce formally the protected modifier. We've seen it before, but now we're gonna do that. They also introduced string tokenizer. I can't remember if I left this in the slides. I'm gonna zoom ahead here. I mean, again, we've done this before. I think I may have pruned that and did not, yeah, I don't think I have string tokenizer in here anymore, but this is where they originally brought it. There's no reason to reintroduce it. Okay, so all those things we talked about, visibility and stuff, we'll get to, but the big thing here is inheritance and polymorphism, polymorphism really. So we can model different kinds of things using inheritance. For example, suppose we want to model dogs and cats as different kinds of pets. So pet is a superclass, dog and cat are subclasses. Okay, so let's put that in Java. We're going to do this. Okay, so we have a class pet, and we'll give it a main method. No need to rewrite that. Okay, there'll also be subclasses. Okay, so class dog extends pet, and class cat extends pet. Okay, very simple. Now, pet is not going to be a terribly complicated method. It's going to have one bit of data and one method. So the data it has, we'll have a string name. We have that, and then the method that it gets besides main will be speak. Speak. Void. We'll do it return. That's going to return a string. String speak. Okay, and I'm going to start off with return. Hi. My name is. Okay, so it's going to return that. Now, pets are going to behave differently, right? We know that cats and dogs are not the same. They're going to act differently. So we'll start off with pet. We're going to call pet p equals new pet, and then p dot speak. All right, I guess we have to give it a name first. Let's make the constructor, we'll give it a name. So pet. We're going to send along a name here. Okay. And our new pet will be named, I don't know, Beast. Okay. Very good. So we run the, oh, there's some kind of mistake in here somewhere. Class dog, why don't you like it? No, I'll add in the constructor. Okay. We'll do the same thing. We'll just do it the way we do it here. Like that. I'll do it here. So fine, we put in our constructors. That's great. And then for here, for cat, we'll do the same thing, except, of course, they're going to be cat. Okay, so we have our constructors in place. Very simple. We run the method, or we run the class, pet, and oh, I guess I didn't print it out. Okay. Where's my main? Yeah. Okay. So we're going to print out the results of speaking. Ta-da. Hi, my name is Beast. Great. Now dog is going to do something similar, right? So dog also automatically inherits the speak method. Okay, so I'm going to mention here, dog automatically inherits the speak method from pet. It's already hardwired in there. Okay, so for example, I could do dog D equals new dog. And I'll name the dog, I don't know, Fido. Okay, and I can do that same thing. I can call speak for Fido here. Okay, let's make this I'm going to say dog says. Okay, let's run it. Right, so we understand dog automatically inherits the speak method, and there's the proof of that. Cat, however, we can override it. Okay, we're just going to do that for cat. For cat, we'll override the speak method. That means, although we inherited it, okay, and it will be present in cat, we can have it do something different. Okay, so we're going to do that for that. We're going to do string, speak, and the cat says, return, no way, man. You're not the boss of me. Okay, let's punctualize. All right. Punctualize, that's good. Punctualize, capitalize. Okay. Oh yeah, and we got to call it. So we're going to make a new cat. Okay, so again, cat C is the new cat. The cat's name will be, I don't know, Fluffy or something. And then system.out, print line, cat says, okay, so we can override it. Cat's not going to say the same thing. Cat says, no way, man. Okay, so that's overriding. That's one thing you can do. And again, we've seen it. We've seen how methods are inherited. We've seen how they work, but this is just a refresher on that. But the other thing we can do, let's give dog a different method. But we'll give dog a fetch method, okay? And we know dogs fetch and cats don't, so that's what's going to drive what's going on. Not all dogs fetch. My dog is pretty half-assed about it. He'll like fetch once or twice, and then he's like, dude, unless you're giving me snacks, playtime is over. So that's how our dog is. Anyway, give it a fetch method. String fetch return. Okay, fetching now. Okay, because he's a dog and he wants to fetch. Cat, on the other hand, cat doesn't fetch, right? Pet doesn't fetch, right? So we can do that as well. So string, I'll do fetch here for cat. return, are you kidding? Cats don't fetch. I know, and right about now is the point where in the class somebody who owns a cat says, my cat fetches all the time. Okay, sure. Some cats fetch, but not all of them, not as likely as dogs. So we can again add in another line here and here, and we can try to do it here. Okay, but it's not going to work. All right, so pet says, and you'll see there is no fetch method. Okay, so for pet, can't do it. There's no fetch method defined for pet, so that won't work. All right, so I'm going to mention here no fetch method in pet. However, we can do it for these, of course. All right, we can do d.fetch and we can do cat.fetch. Okay, so this works. All right. Now the interesting thing is if I try to go through a pet reference, right? So once again, suppose I try to use a pet reference to access the dog or cat data. Okay, methods. Let's say the methods. So if I say pet PD equals D, okay, so I'm going to say basically PD is D, all right? I can try these same things. I'm going to say, I'm typecasting it to a pet, that's why I'm putting it in parentheses. Okay, but once again, I can do speak. If I try to do fetch, fetch isn't going to work. Okay, once again, if I'm going through a pet reference, can't use it. So, can't use non-pet methods through pet reference. Even though it's there in the dog class, if I'm going through a pet reference, I can't use it. Okay, but I can still do speak because speak exists for pet. Now, for the dog, what is the dog going to do? The dog is going to say the same thing that a pet will. So this isn't going to tell us anything. All right, so dog says the same thing. Hi, my name is Fido. We'll do the same thing with the cat. Okay, and as we'll see in a moment, it'll be a little different. So suppose I try to use a, I already have it in there, so I'll just do the second one. Okay, so pet PC equals C. So once again, PC is C. It's actually the same thing as that cat. If I do these same same methods, I'm going to typecast them here. So pet cat and pet cat. I'm going to do PC and PC. Okay, so once again, can't do fetch. So I'm going to comment that out and borrow the same thing. Okay. But this is the interesting one. So right here, PC.speak, watch for it. Pet cat says, no way, man, you're not the boss of me. So I'll make the point here. Pet cat uses cat's version not pet's version. Okay, so it's an interesting thing that when we look at how this is stored in memory, if I try through the object reference to access a method that actually exists in employee and in object, right? If it exists in object, I can use it. But if employee has overridden it, I'm still going to use the employee's version, even if I go through an object reference. Okay, and again, this is a wonderful, flexible thing in terms of arrays, because why? I can still do many things customized for classes, even when I go through a superclass reference. Okay, so for example, if I have a bunch of things stored in memory somewhere, and I have a bunch of things stored in memory, in this array, I will still be able to use the subclass version of any methods, not the superclass version. The reason why this is nice is, again, that means that's that much less code that I have to rewrite. So if I have, for example, a bunch of subclasses of employee, okay, suppose I have various subclasses of employee with different with methods that override the employee methods, like for example, like calculate pay methods. They will automatically, or I'll say by default, use the subclass version of the method, not the employee version. And again, this is a wonderful thing. If you have a stretch of code that says, you know, this employee dot pay, it's nice that I don't have to go through the code and tweak that for every possible method call there, okay? Because there could be a lot of method calls throughout the code. Instead, all I have to do, I define a new employee subclass. As long as it has that, you know, pay method in there, that employee can be easily integrated into the array. The array can store it. When I call the method pay this employee, it's going to use the pay method that's specified for the subclass. So again, you can introduce a lot of subclasses into your arrays or other structures and not have to rewrite too much code. And this is a wonderful thing in terms of scalability. If you're some big enterprise operation and you have these monster programs covering lots of different aspects of your business, it's nice to minimize that workload, to be able to modify things, modify classes somehow, and yet not have to dig through all of your millions of lines of code and change everything for that. Okay. Questions on any of this? How's everybody doing? Still there? All right, I'm going to cover in just a little bit more, then we're going to call it a day so we have some stuff left for tomorrow. Okay, so here's the pet class, right? Subclasses of pet class, examples. This is the stuff I basically covered. Now, the next thing, the specific example they give here, defining some classes with inheritance, right? So suppose we want to implement a class roster that contains both undergraduate and graduate students, right? And there's some data and there's a special way to calculate the course grades. Okay, so for the two different classes. So let's talk about this. I'm going to introduce the problem, then we'll come back and actually work it out on Wednesday. All right, so basic problem is we have two classes of students, okay, undergrad and grad. They are taking the same courses, right? So that's a thing, but their grades will be calculated differently. Like, for example, each takes 3 exams, but the undergrads drop their worst grade. The grad students just take the average of the 3 exams. Okay, so this makes it, we can understand how this is going to work. There's implicitly going to be some superclass student, and then down below that, we're going to have a couple of subclasses, right? So one will be guess I'll have to do. The other will be undergrad. So graduate, so I'll call it G student, and I'll call this U student. Okay. And if student has the method, student has the 3 bits of data, exam 1, exam 2, exam 3, right? Then student can also have the method grade, right? So that's going to work in a different way. So graduate student is also going to have its own custom version of grade, and undergraduate student, right? Maybe that uses the inherited one. Oh no, graduate student, you'd use the inherited one. Okay, so undergrad student overrides grade. Graduate student will use the default method. All right, so this is the structure of what we're going to do, and we're going to have an array of students for our class roster, and we're going to randomly pick them as being undergraduate or graduate. We're going to randomly give them some grades, and we're going to fill out all the boxes and determine their grades. Okay, that's basically what we're going to do on Wednesday. And so we'll dig a little deeper into this. We'll learn a few new things. Okay, any questions on any of this stuff? I hope it all makes sense. I'm going to stop the recording now, if I can successfully execute that.